Hi class, I'm going to show you a few examples from the section 1.4 homework. This is operations with rational numbers. The first thing I want you to remember is what exactly is a rational number. Basically, a rational number is any number that can be written as a fraction. This could be positive whole numbers, negative whole numbers. It could be fractions themselves. It could be terminating decimals, which that means decimals that actually come to an end. It could also be repeating decimals. The only types of numbers that are not rational numbers are called irrational numbers. And those numbers are examples like pi, which is 3.14, and then on and on and on. Or when you take a square root of a number that's not a perfect square. So for example, if you try to find the square root of 15 or the square root of 23, that's going to produce this never-ending decimal, and so those numbers are called irrational. So I'm going to run you through a couple homework examples. I hope you've already been in class when I taught this lesson, or you've watched a few videos online about this. I'm going to show you the operations with fractions. I won't be teaching you operations with fractions on this video. I'm just going to quickly run through a couple examples. Take a look at this first problem. It says find the sum and write the result in simplest form. When adding and subtracting fractions, you need to find common denominators. This example, the common denominator will be 10. Now you need to convert the numerators. The first fraction we multiplied by 2 over 2, and so 2 times 3 is 6. The second fraction we multiplied by 5 over 5, and so the second numerator is 5. Okay, you can add across the top. 6 plus 5 is 11 tenths, and you should be able to leave it as an improper fraction on WebAssign, and so that's your final answer. This example says find the difference and then write the result in simplest form. So just like the addition problem we just worked, this subtraction problem also needs to be rewritten with common denominators. This time the denominator will be 20. The first fraction was multiplied by 5 over 5, so the numerator is now 5 times 3, which is 15. The second fraction was multiplied by 4 over 4, and so the numerator is 2 times 4, which is 8. Now that the denominators are matching, you can subtract across the top to get an answer 7/20. Okay, this one says evaluate the expression, write the result in simplest form. This is a multiplying example, and you do not need to have common denominators. And we can actually just multiply the two numerators together, and then you can multiply the two denominators together, and then simplify if needed. Also, when you see a negative sign in front of a fraction, just let that negative sign tag along with the numerator. And so this will be negative 2 times 7 is negative 14. 5 times 9 is 45. And that cannot be simplified. So that's your final answer. Okay, this one says evaluate the expression and write the result in simplest form. This is an example of dividing fractions. And the way I taught you in class, or maybe you've seen a few videos, I want you to rewrite every division problem into a multiplication problem. And here are those steps. You're going to write the first fraction. You're going to keep that the same. And I want you to change the division sign to multiplication and then find the reciprocal of the second fraction. Reciprocal is a fancy word for flipping the fraction. And then I want you to notice that these numbers are a little big to multiply, 16 times 25, especially if you're in my class and I won't let you use a calculator. And so we've talked about this concept of canceling first before we multiply. And you can, so for example, 16 and 8 both can be divided by 8, and that leaves us with 2 and 1. 5 and 25 can be reduced to 1 and 5. And so an equivalent statement is 1/2 times 1/5. That's what it looks like after we've simplified. Now we can multiply straight across to get an answer of 1/10. And the last thing I want to show you is how to find the greatest common factor. The method I use in class is letting factor trees help determine the greatest common factor. So that's what I'm going to do on this video. I'm going to quickly make 2 factor trees. Okay, here are my 2 factor trees. I worked those out pretty quickly, and if you have questions about how to make a factor tree, please let me know. Now looking at these 2 factor trees, I want you to circle every number that they have in common in their prime factorization list. That is the list of numbers here in this red box. So they have 3 2s in common, and that's it. And so the greatest common factor, GCF, is 2 times 2 times 2, and a better way to write that is 8. That's all for this video. Please let me know if you have any questions about this homework assignment.